very much, Linda, for that nice introduction. Okay, so I'm going to talk about some research that I've been doing recently, and this is joint research with Jerry Behrman, is also a professor in the economics department. Susan Parker is a professor at University of Maryland, and Wei Long Zhang is actually a former graduate student from our department, and he's now at Cambridge University. Okay, so we study in this paper something that's called conditional cash transfer programs. And these programs were first started in 1998 in Brazil and in Mexico. And these are programs that pay families to send their children to school. So you can think of it as kind of a welfare program, but they're implemented in like developing country settings where, child labor is often a problem, and so the children aren't going to school as long as they might, and they have two goals with these programs. One is just to reduce poverty, because they're targeted at the poorest families, and the other goal is to increase schooling so that the next generation is going to be less poor, and to provide more incentives to put children in school. And the other thing that they did is they actually gave the money to the mothers. So it also was kind of an empowerment program for the women in the family. And then the transfers were increasing with the age of the child, and the transfers were a little bit higher for girls than for boys, because girls were dropping out of school earlier. And so I was involved with the Mexican government in 1998, and at that time they did a randomized control study where they had 506 villages, and they randomized entire villages to either be in or out of the program. So they had treatment villages and control villages. And then they were followed for 2 years, and then they gathered lots of data. So about 50,000 households participated in this, and they interviewed them about everything, like whether they started businesses and housing characteristics and schooling and health. These programs also required that they take their children for health monitoring, and they were trying to increase nutrients for kids that were too short, because they have a big problem of stunting in that country. And the results were very encouraging. So I was on the team looking at the education outcomes, and it did increase schooling. Like, there was no doubt about it. The sample sizes were really large. It was experimental. And then a lot of other countries took notice of this program that seemed to be working, and the World Bank also put a lot of resources behind these types of programs. And so they actually, eventually 60 countries around the world ended up adopting similar programs. So like millions of people became part of these types of programs. Brazil and Mexico were the first, but I think the Mexican study had a lot of influence because it was experimental. And in Brazil, they didn't do a randomized experiment. And so then they also have done since then other randomized experiments, like in Africa and Asia. We have different examples of some experiments. But the one thing that people really did not study that much is whether it increased learning. And there have been some people that are critical of these programs, including, for example, like Esther Duflo at MIT. I mean, she was one of the winners of the Nobel Prize. She never worked on these programs. I think she has one paper actually looking at CCT programs, but she's not a huge fan, and so she kind of wrote some negative things about these programs. And she is saying that there's no evidence that it increases learning, that yes, the kids are going to school, but maybe the schools are bad quality, and so therefore their learning is not increasing. And the reason we haven't really been able to look at that is that we didn't have the data on test scores to really be able to follow whether learning was improving or not. And so we recently got some data from the Mexican Ministry of Education, and it's all the test score data from like 2007, 2008 until 2013. So it's this window when they gave these national tests in Mexico, and they gave them in all schools in all states, private and public schools. So actually in the US, you don't have that kind of data, because in the US, every state does its own thing. and then private schools don't take the same tests. So it's a really rich data source, and we're trying to use these data for a lot of different projects. It includes information on 43 million school children over time, so you can actually see their test scores evolve as they age. And then they also gave surveys to a random sample of schools in each year, and that was about like 3.5 million children took these surveys. And also their parents filled out surveys, teachers filled out surveys, principals. So it's like this huge database. I've actually been buying bigger computers to even be able to store and work with these data. And so the question we examine in this paper is, we look at the effects of this program on school enrollment and educational attainment, but in mathematics and Spanish. So we do look at enrollment. It's already kind of accepted that it does increase enrollment, but the main focus is like, did it increase test scores? Okay, so a major challenge, if you think about evaluating this type of program, is what we call dynamic selection in the economics department. So the problem is that this program brings children to school who would otherwise stay home. And so those kids probably are at the bottom of the test score distribution. So you're bringing in these children that otherwise would not be at school at all, and then you only measure test scores for the kids going to school. So there's a tendency to find that when you implement the program, test scores might go down because you're bringing kids in from the bottom of the distribution. So we have to control for this selection, and it's dynamic because it occurs at each grade. So at every grade, the kids that are there depends on the ones that came from the previous grade. So we actually build a mathematical model. So the machine learning, or not machine learning, we use different tools. I'll describe a little bit the tools, but it's part of like a dynamic mathematical model of test scores and then also school choice and the decision to go to school or not. Okay, so you can see here, these are the kids that are dropping out. And then there's also a thing in Mexico where they have some choice over what type of school to go to. And in very rural areas, they actually have something called telesecondary schools. And those are schools where you get your lectures through video. Like you go to a school, but the instruction is over the video. And this is because in remote areas, they don't have middle schools necessarily. So a lot of the kids that are in this conditional cash transfer programs are attending telesecondary school. So that's why we also attempt to model the school choice as well. So you can see like here, this is the proportion attending telesecondary for progressive beneficiary, or the name kind of changed. So it started off Progressa, then it was Oportunidades, then it became Prospera during our data collection. But these are the children that are in the program, and you can see a lot higher fraction is going to telesecondary, and these are the dropout rates. So by 9th grade, 26% already dropped out. So we combine a lot of different data sources in the study. So one is this test score database, the survey data. We also, because a major decision of whether you go to school and what type of school you go to is distance to the school. So we also geocoded all the school distances to see how far kids are located from the schools. And then child labor is common. Like 8% of kids that are 12 years old are working in our database. And so we used Mexican census data to get an idea of the wages that the children earn when they're working. And we follow 4th graders in 2008 for 6 years and just focus on public schools. So this just gives you an example of, this is just raw data, so we haven't done any modeling here yet. But you can see there's a big gap between the Prospera beneficiaries and non-beneficiaries, and the gap is shrinking. But it could all be due to selection because the Prospera beneficiaries are actually dropping out earlier. So we don't know for sure, is it that their test scores are actually getting better, or is it that the kids that are kind of low in the distribution are just dropping out? So that's why we really need a model to be able to control for these like observable selection as well as like unobservable factors. Okay, let's see. Yeah, so we combine two different types of models, and there's big literatures, also I think in education, but there are a bunch of economists that work on education topics. And so we do something called value-added modeling, where your test score today depends on your test score last year, or your test score this grade depends on last grade, plus intervening investments. So what school you went to, you know, it could be family background. So it's a cumulative model. So if you improve test scores in fourth grade, that could actually, you know, affect future grades, because then maybe you can learn better in fifth grade because you were able to master the knowledge in fourth grade. You know, so it really is like this dynamic process. And then we also, we combine it with a school choice model. Let's see. Well, I think I pressed the button by accident, but I'll just say what was on the other bullet. So we combine it with a school choice model where the children decide not only whether to go to school, but also what type of school to go to. And they actually have a school type called indigenous schools, because there are a lot of indigenous children. And so in primary school, they can actually go to indigenous school or regular school. Indigenous schools are not taught in Spanish. They're typically taught in like the local language, which actually, you know, could be an issue, because when they go to middle school, they don't have indigenous languages anymore, and so it could make it actually harder to make the transition. So that's why we tried to model indigenous versus regular plus different types of middle school. So in terms of observable heterogeneity, we have a lot of family background information. So the children in the program, their parents have less education. They typically come from very large families. A lot of kids have 6 or more children in the family. They have a lot of intergenerational households. Their housing characteristics are a lot worse. You know, like they have a dirt floor, or they cook and sleep in the same room. Like those are the types of variables that we use when we control for observable differences. And then the model starts at grade 4 when we start seeing their initial achievement test scores. Okay, and the other thing that we did actually in this, I mean, part of the contribution of the paper is like to come up with a way of modeling these different things. So there are a lot of children where the probability that they would be in this program is 0. I mean, think of like someone who has college-educated parents, lives in Mexico City, you know, they have nothing to do with this program. They're not at risk for this program. So we actually just estimated a probability of being a beneficiary, and we only focus on people. I'll show you a graph of it's called a propensity score, where it's just your propensity of getting this treatment. And the ones that had basically 0 probability, we just don't include in the analysis, you know, because they're like not comparable at all to the kids that are in the program. So that's the logit model. So at different stages, we kind of use different techniques. Let's see. Yeah, and we have a very high, we're able to classify them pretty well because we know the criteria for being in the program, like the eligibility criteria, and we have most of that information. A lot of it is housing characteristics. Okay, so that gives you an idea of the propensity score distribution. So the green are the non-Prospera. So we basically trim out only the bottom bar. And then we focus our whole statistical analysis on the Q is quartile 1, quartile 2, quartile 3, and quartile 4. And we're also going to look at the impacts of the program separately by quartile. So quartile 4, these are the poorest households. Those are the ones that have the highest probability of being in this program. You know, so you can think of them as the poorest. And so we're going to estimate program effects for different groups. Okay, so it's allowing a lot, in economics, there's been a lot of emphasis on allowing for heterogeneity and how people respond to treatment. We don't want to assume that everybody would respond the same way, you know, so That's why we're kind of breaking it out. Okay, so the model is like kind of this mathematical model that takes a few pages, but this gives you kind of a graphical representation of what are the things we're modeling. So it starts in grade 4. In every grade, they can fail. Because actually, you know, in the US, it's pretty rare to be held back. But in Mexico, it's not rare at all. They give tests at the end of the year, and if you don't pass those tests, you're at high risk in not going to the next grade. So when we look at our sample, we see kids that are like in 4th grade twice and 5th grade twice. You know, so we have to allow for grade repetition. And so that's what this little loop is. This little purple arrow means you do it again. That's like you repeat the grade. So in 4th and 5th grade, they can actually go to general schools or indigenous schools. Very few kids drop out, so we don't allow for dropout here. But a lot of children drop out after 6th grade, because that's when they make the transition from primary school to middle school. And then the middle schools normally are further away, and they don't have school buses. So they might have to walk a couple kilometers or something to get to school, or miles. So you can drop out. So that becomes very important. Then you can decide from 3 different types of schools. So the different types are general, telesecondary, and technical. And different people have different options depending on where they live. So we try to take into account in the choice model, what are their options? So that's where we're using the geocode data about what schools are within like a 10-kilometer radius. That's what we say are their options. And so at each grade you can fail. So those little purple arrows are still possible. And then you can drop out. So you can either advance to the next grade, repeat the grade, or you can drop out. So these are kind of all the different things that could be happening. And we try to, our model is trying to use all the observable characteristics to explain these things, along with test scores. So we're observing in each year their test scores, and we're trying to model the test scores as how they accumulate, plus all the schooling decisions. So it's basically a schooling model. I mean, we have a lot of different types of dynamic schooling models in economics. Okay. Yeah, so that's kind of a picture of our model. But these different, in terms of tools, like this is a multinomial or a multinomial logit model for like the school choice component. And then the value-added model is just like a regression model, but with lag-dependent variables. So it's using different, I actually teach econometrics, and so it's using kind of different econometric techniques. That's what I teach at Penn, is undergrad and grad econometrics. Okay, so these are now, after we estimate this whole model, then, you know, we get all the model parameters, then we can simulate what if we took away the program. So we have all the people that are currently in the program, and we're going to simulate what would their outcomes look like if we took it away. And that's what this P tilde is, if we took away the program. Okay. So P1 is with the program, and P tilde is for the same people if we took away the program. And you can see that we're finding like no test score benefits. These are average test scores. So there's no benefit in 5th and 6th grade, but in 7th, 8th, and 9th grade, we find a pretty big test score benefit. This is actually, 10 is like 0.1 standard deviation. So it's, you know, so we're finding big effects on math. It's bigger than on Spanish. And then we also simulate the dropout, and we're finding it reduces dropout, school dropout, to be in the program, especially during that transition from 6th grade to 7th grade. That's when the dropout really decreases. Okay, and here you see the effects broken down by the poverty quartile. So the poorest category are these families here. And then these bars here are standard error bars, these little bars. Okay, and we see a pretty clear pattern that the poorest families experience the biggest benefits from the program. And we always saw that math is a little bit bigger benefit than Spanish. The other thing the paper is actually pretty long, and so there are a lot of different results. I just kind of took out some of our results. But we also looked school by school, like for different school types. And we found an interesting phenomena, which is that telesecondary is very good at teaching math, and that's where they get video instruction. So there's a concern in a lot of countries that the professors don't know the math that they're teaching, because, even in Mexico, if you look at their curriculum, their high school curriculum is more advanced than in the US. Like kids are taking integral and differential calculus in high school and statistics, which they wouldn't take in the US. So they have a serious concern about whether the teachers really know the material well enough to be teaching it. Of course, this is middle school, so I hope the teachers know what they're teaching. But the video instruction, they pick star teachers. And then they see the video recording, and then they have a local teacher that kind of facilitates their learning. So it's not like over the internet. It's not online because a lot of the children don't have laptops and don't have internet. So they do physically go to a building, but then they just see the lectures through video. So we were surprised that this mode of instruction seems to be pretty effective. And there are many other countries that struggle with how to get advanced instruction to people in more rural areas. In Africa, I think this is a problem in a lot of countries. So I think this is interesting, because Mexico's had telesecondary school for I think since the 1970s. And so it's interesting that it seems to actually work. And we didn't appreciate that so many of the Prospera beneficiaries were going to those schools. I didn't realize that. Even though I worked on these programs for 20 years, it was just looking at this database where we kind of realized how important those types of schools are. Okay. Let's see. So that's basically, just as model of school progression, academic achievement, the main challenge is selectivity. That's a challenge in many economic applications. That's the big challenge with observational data, like Linda was saying. Most of our data is observational, but interestingly, if you had a randomized experiment, you'd still have that problem because usually the tests are given in school. So even if you did a randomized experiment, it doesn't solve that problem. You'd actually have to go give the tests at home to be able to capture the results for the kids not going to school, So in this context, you couldn't solve that problem with an RCT. We're still trying to understand why the programs seem to have no effect in grades 5 and 6. I think in those grades, kids are going to school anyways, because it's pretty unusual to drop out in grade 5. It's after you finish primary school is the big dropout. And then also after grade 9, there's a huge dropout because only 30% go to high school. And pretty big effects we're finding in math, 0.1, in between 0.1, 0.15 standard deviation, which is actually kind of a typical effect for an educational intervention. It's not out of the range of what people find sometimes. Largest benefits for most disadvantaged. We also simulate taking away the telesecondary schools, and we find that they're very important, and that a lot of kids would be dropping out if they didn't have that option. Okay, I think that's the last slide. So. Okay.